So the recording has been started now, and let me minimize this. I'm so sorry I couldn't upload the video of yesterday, so it's uploading right now. And let's go ahead and start module 5 with virtual machine movement and Hyper-V replica. Most of the things from here on, we will not be able to install it completely on our server. For these lessons, we need to focus and we need to understand how things happen, because mostly what happens is we need more than one server to work or practically on this. But I have only one server, so there are few things that we will not be able to do it practically. Okay, so let's go ahead and start with lesson one: providing high availability and redundancy for virtualization. As of now, you might have understood what is high availability and redundancy. In the server world, it's very important that you need to have high availability and redundancy, because even for a single restart, it might a company might lose thousands of dollars to millions of dollars. When providing redundancy and high availability for virtual machines, you can choose from variety or even a combination of methods. Some of these, such as failover clustering, this is one of the high availability. Network load balancing, NLB, is one of the load balancing. Network adapter teaming, NIC teaming. I have shown you what the NIC teaming is while we were doing networking class in module 4. So NIC teaming is also one of the high availability are parts of the operating system. Other applications such as Microsoft Exchange Server 2013 and Microsoft SQL Server 2012 also include their own high availability features. So let's go ahead and see. After completing this lesson, you will be able to discuss the importance of high availability, explain the redundancy in Windows Server 2012 R2 and Hyper-V, describe the use of NLB, network load balancer, to achieve high availability at the operating system level, describe the use of clustering to achieve high availability at the operating system level, describe high availability at the application level. Why is high availability important? In an ideal computer environment, servers would always be available and free of failure. Bandwidth and other resources would be infinite, and you would not need to worry about high availability. In reality, server downtime is unavoidable, and you need to consider this when you are planning to provide uninterrupted service that must be constantly available. Such uninterruptible services include virtual machines, because some virtual machines will host critical systems such as email, database, or file service. What high availability is? Suppose you regularly go to a website like gmail.com. What if one server is off for about 30 minutes? What will happen? Nobody in the world can log into Gmail account. So how this will impact to Gmail, to Google? Gmail does lot of advertising and they earn from that. So if their website is down and if this frequently happens, people will move from Gmail to some other webmail. So it's actually a discomfort. Just try to think. You're using YouTube and all of a sudden You cannot use a YouTube for about 30 minutes or 1 hour because some servers in you at the YouTube got shut down for some reason. So this is in terms of YouTube or Google. But when you work in a company, when there is an important application, suppose you work for HP, HP.com is a very busy website. What if one day I put HP.com, nothing comes up? Suppose why we will go to HP.com? Suppose I have to buy a laptop. I go to HP.com and it won't come up. Now what I will do? I will try to go to some other website and buy and take the thing because my need is to buy a laptop, right? So I will, my need will be done. My need will be taken care. No matter if HP is available or HP is not available. So every company will definitely have few applications that are very, 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 very important. That means that servers cannot be shut down or restart or there is nothing can be done. And there are also levels of high availability. So let's see what is high availability. High availability means the system and service are up and running, regardless of what happens. I don't care what happens to a server. Okay. I want this server to run 24 by 7, 365 days. I need such a service because my whole business is because of this website or because of this application. If it's that important, then we there are the ways. So as an SC, what I will say, okay, if it's that important, then let's go ahead and do NIC teaming. We will have four NICs on the server, bind it. We will do NIC teaming, and we will use that four NICs as one NIC. So if anything happens to one NIC, no need to worry. We still have three, right? This is one way of keeping the server running. One way to keep the server running, and two power supplies. One power supply connected to one um, switch, the other service, other power supply connected to another switch. So if anything happens to this power switch, it, my server will still be on because it's getting power from other power switch also. And similarly, they can have hot spare hard disk. This is also one type of for high availability. If anything happens to a hard disk, no need to worry, the other hard disk will take over. Similarly, now I have one server, now clustered it with one more server. So if my one server got failed for some reason, I have one more server. This is also high availability. Now, let's take a natural disaster. I am in California. Something happened, a big wave came, complete California is down the ocean now. Now what? Is Dell going to shut down or HP going to shut down because California is no more? Or if there is such a bad lightning where all the California is washed away, is few of the companies going to shut down? Is Google going to shut down? No. because they will have one server in California, the other server is just sitting in India. So if anything happens to this server, the India server will take over the complete load because it's in the cluster. And this is also an high availability. And if anything happens to India server, there is one more server sitting in China in their data center. It can take over the complete bandwidth, complete workload. This is also a high availability. The goal of high availability is to make system and service as consistently available as possible and to eliminate as many potential single point of failures. Availability is often expressed numerically as the percentage of time that a service is available. For example, a requirement for 99.9% availability allows 8.75 hours of downtime per year. So if I say someone or somebody says, "Sir, I have an application, I want to put it on the server," the application can only be shut down for 8.75 hours per year. So at that point, we can give them a suggestion of saying this will be needed, or approximately 40 minutes of downtime every 4 weeks with every month. So servers do get restarted. Remember that whenever we patch the server, and we do patches every month mostly. So as we patch the server, we have to restart it. So sometimes, depending upon the server configuration, the server will may come back within 15 to 20 minutes also. However, with 99.999% uptime, the allowed service downtime reduced to only 5 minutes per year. This is not possible at all. Service downtime reduced to only 5 minutes per year. If your service or virtual machine is running on a single system, these high availability rates are virtually unachievable because a single restart will most likely use up those 5 minutes. In addition, many actions such as upgrading hardware or applying updates require system restart. No matter how reliable the hardware is, components fail from time to time. Although rare, power outages or natural disasters such as earthquake or hurricane are always a possibility as well. So we need to know before deploying a server, like what what exactly the application team needs. I mean, how important the application is. Sometimes there might be some applications if you don't need it for 2 days, you have no issues. It's not that important. There is an application which is very important. So depending on that, we will use a solution for high availability. To make a virtual machine highly available, you must first ensure that the hardware on which it is running is as reliable as possible. You should store virtual machine data files on a shared storage so they are still available even if the physical host fails. You should then provide redundancy to all components, including power and networking, by using redundant power supplies. physical network paths to virtual machines. There is no benefit if the virtual machine is running, but clients cannot access it because of network failure. Can you ensure high availability by simply copying the virtual machine that is providing a critical service and making both the original VMs and the copy available on the network? Yes. If you need it, then yes. Redundancy in Windows Server 2012 R2 and Hyper-V. To make virtual machine highly available, you must deploy it in an environment that provides redundancy for all components and make it available even when failure occurs. The most basic high availability strategy is to ensure that hardware is as robust as possible, thereby minimizing failures in the pass, in the first place. Windows Server 2012 R2 provides high availability features such as NIC theming, node load balancing, and failover clustering. We have seen NIC theming, node load balancing while we were doing networking, and failover clustering. I have sent you a video last week to go over it. Hyper-V builds on top of the Windows Server 2012 R2 high availability features by introducing its own virtualization specific features such as live migration, live storage migration, Hyper-V replica. Hyper-V builds on exclusive exclu- and includes the following features: hardware failure. Hyper-V benefits from Server 2012 R2 availability and serviceability. In addition to Windows hardware error architecture, which provides a common infrastructure for managing hardware errors on Windows platform. With Hyper-V, if a memory error is detected at a memory location, the Hyper-V does not use it. It will mark as bad in the future and the operating system will not use it. If the memory error is in the physical random access memory (RAM) that the virtual machine is using, only that virtual machine will be affected. The entire host and all virtual machines will fail only if the memory error is in physical RAM that the Hyper-V host kernel is using. This is the new architecture. Suppose take your RAM, take your own laptop. If anything happens to your memory, your RAM, your laptop will crash, no matter where it is. So that's what it's saying. So suppose a part of memory is not working and there are two virtual machines on it. So that two virtual machines will be affected, not the complete RAM or not the complete hypervisor. The complete hypervisor is only affected when where the hypervisor is installed, that part of a RAM has an issue. Physical server failure. Hyper-V uses the failover clustering feature to provide redundancy if the entire physical server fails. The failover clustering feature is part of Windows Server 2012 R2, so it's not a part of the Hyper-V, but Hyper-V uses it. If the server in a node in a failover cluster, virtual machines that were running on it will fail over automatically on other cluster node and will be available for minimum downtime as a result of a virtual machine reboot. Hyper-V also includes the migration, which enables you to move the virtual machine between Hyper-V hosts without downtime. Input-output redundancy. Windows Server 2012 R2 includes several features such as SMB 3.0 multi-channel storage, multipath, NPIO, NIC theming, node balancing, which can provide high availability benefits from network path redundancy if the network adapter or other infrastructure fails, Hyper-V uses the feature to preserve network connectivity. If there are multiple network paths between the source and destination, and if network equipment of one of those paths fails, Hyper-V uses this feature to maintain connectivity to the virtual machine. Application or service failover. If a service or application inside the virtual machine fails or loses network connectivity, Hyper-V host can detect it, try to recover the application by moving the virtual machine to another node. You also you can configure failover clustering inside virtual machine either by using Internet small iSCSI or fiber channel. In the same way that you can benefit from teaming physical network adapters on the Hyper-V host. Disaster recovery. Windows Server 2012 R2 includes clustered shared volume (CSV) integration with storage arrays of for replication. This can provide protection against disaster at a single location because Hyper-V hosts are also at the alternate location and accessing replicated storage. However, Hyper-V also includes Hyper-V Replica, a feature that provides synchronous replication of the running virtual machine to an alternate location with considerable intervals. Hyper-V Replica failover requires virtual machine downtime during failover. Using load balancing for providing high availability at the operating system level. So whatever you are seeing right now, high availability, redundancy, NBL, these are actually a part of Windows Server 2012, not a part of Hyper-V. But they are very important features, and Hyper-V uses this. Yes. NBL is an effective and scalable way to achieve high availability for stateless service such as web servers. The term stateless refers to workloads that respond to each request independently from previous requests and without keeping client state. For example, when a client requests a page, the web server gathers all the necessary information from the request and then returns the generated web page to a client. When the client requires the next web page, it may request the web page from the web server or from any other identical configuration web page in the NBL farm, which is because all the information that the NBL server needs is in the request. Using NBL to achieve high availability provides the following benefits. NBL enhances the availability and scalability of other Internet server applications, file transfer protocols, firewalls, proxy, VPN. All the Windows Server 2012 R2 edition includes NBL feature. You can include up to 32 servers in an NBL farm, and you can add or remove a server dynamically from the NBL farm. For a load balance service, the load is redistributed automatically among the servers that are still operating when a server fails or goes offline. If the failure is unexpected, only active connections to the failed servers are lost. When you repair the server, it can rejoin NBN farm transparently and regain the share of the request. Hyper-V can use NBL for load balancing requests for virtual machine on the same Hyper-V host or for virtual machine across multiple Hyper-V hosts. When you use NBL in unicast mode to distribute load among virtual machines, you must enable max spoofing for the virtual machine network adapter. This is because the network adapter does not use its own media access control, MAC address, but the MAC address is Minicap MLB. If multiple virtual machines will be a part of same NBL farm, should you configure them with the same IP address or with a different IP address? Using cluster to achieve high availability at the operating system level. I send you a video of this and I hope you guys have already went through it. So I'm not going to continue. I mean, I'm not going to go into this, but I will briefly give you some information. So, what is clustering? So, in an Hyper-V, what exactly we do? This again, clustering is not a Hyper-V component. It's a Windows 2012 R2 component. So, what usually we do is we install failover clusters on both the servers. There should be two servers to make a cluster. In a We install failover clustering on both the servers, and we need additional IP addresses. So we put all that information and then create a cluster. So what happens is, if one server dies, the other server will automatically take over the workload of the server where it was working. So all the data goes to another server now, and the work is getting done. So why are we doing this? Suppose we have an important application and we want it to run 24 by 7, 365 days. So if we have this clustering done and suppose we have to restart a server, so we can restart the server. So and by that time, all the data from this server gets transferred to the next server, and your work will be done. You will not get to know that something happened behind. One server is restarting, the other server is working on your request. So you have nothing to do with it. I mean, not you. I mean, the application team has nothing to do with it. What application team sees? I want this application to run 24 by 7, 365 days, no matter what. High availability at the application level. It explains about Exchange Server and Windows Server and SQL Server. So Exchange Server and SQL Server, they have always on capabilities, which is their own always on failover cluster instance, always on availability group, data mirroring. These are their own concepts. Where data mirroring means SQL Server mirrors the data and tables, and if one table is corrupted, it gets the data from the another table. Always on failover cluster instance. This means this feature builds on top of a failover clustering feature in Windows Server 2012. It provides high availability to the SQL Server instance level through redundancy, which is called failover cluster instance. And same thing is always on availability group. Implementing virtual machine movement. One benefit of virtualization is that you can move virtual machine between Hyper-V hosts. So I don't have two servers to show you, but what will happen is, as you know how the virtual machine is, right? How the Hyper-V is or how the virtual machine is. So Virtual machine, suppose if I have to move one virtual machine from my host to another host, I can right click on it and I can say move. The option will be there. Move to another host. The virtual machine will move. Only thing you need is you need a shared storage between both the hosts. There should be a shared storage. After completing this lesson, you will be able to describe virtual machine moving options, explain how storage migration works, describe the move wizard, move virtual machine storage, describe live migration of non-clustered virtual machine, move a running virtual machine. So let's see the options. Virtual machine and storage migration, quick migration, live migration, Hyper-V replica, exporting and importing virtual machines. We have seen this yesterday. Let's read through this. Hyper-V in Windows Server 2012 has several options that you can use to move the virtual machine and its data files based on the environment and requirements. You can select one of the following methods: virtual machine and storage migration. So with this method, you can move the entire virtual machine or only its data file from one location to another or between Hyper-V hosts while the virtual machine is running without noticeable downtime. Virtual machine and storage migration do not require failover clustering or any other high availability solution to work. They only require network connectivity between the source and the destination. When you are moving a virtual machine and storage from Windows Server 2012 Hyper-V, a destination server can be either 2012 or 2012 R2. Quick migration. Quick migration was actually introduced in 2008, which you can use to move virtual machine only between Hyper-V hosts within the same failover cluster. This virtual machine is unavailable for a short time during the move operation. Live migration. So, Windows Server 2008 R2 introduced the live migration feature. So, live migration was introduced in 2008 R2. So, remember this option was not available in 2008. It was available in 2008 R2, which is an improvement over quick migration functionality. When first introduced, you would use the live migration feature only to move virtual machine between Hyper-V hosts in the same failover cluster. So this was in 2008 R2. You can do live migrations only between two servers that are in cluster. The benefit of live migration functionality is that there is no noticeable virtual machine downtime. In Windows Server 2012, live migration functionality is improved. Failover clustering is no longer a requirement. So there we don't need any clustering or anything between both the servers to migrate the server. We only need this internet connection, and I can migrate it from here to anywhere. You can move multiple virtual machines from same Hyper-V host simultaneously. Windows Server 2012 R2 provides further improved live migration performance because you can use compression, SMB direct, and SMB multi-channel during live migration. Hyper-V replica. This is a very important concept. So, what is replica is all about is
And this was actually introduced in 2012 only. While the virtual machine is running, you can create a replica of this virtual machine on a different host. It has to be on a different host because you are trying to create a replica. And this replica can, the host can be in the same location or it can be anywhere in the world. Only thing is when you are making a replication server, you will have three options uh, regarding the 5 seconds, uh, every 30 seconds, 5 minutes, and 30 minutes. The data gets copied to a replica server. So there are three options in it. Hyper-V replica. Windows Server 2012 introduced the Hyper-V replica feature, which you can use to replicate a virtual machine synchronously over IP networks, typically to a remote disaster recovery site. With Hyper-V replica, the virtual machine is replicating while it is running, and its changes are synchronized with the replica. In Windows Server 2012 R2, you can configure replication frequency and extend replication. Extended replication forwards the virtual machine changes to a third Hyper-V host. Extended replications means suppose I have a server in America and I am replicating this server with my disaster recovery site in Hawaii because I have a data center there in Hawaii. A disaster recovery site. Suppose my America data center is washed away, or a volcano has busted, or something happened, and my complete data center is ruined. There is nothing left there. There is no human being at all in America. Still, I have a data center in Hawaii. Right? So when I said if there is nothing in America, the complete America is washed away. Now what? Shall I close it down my business? I have one more data center in India. So I'm replicating data from here to Hawaii, from Hawaii to India, or some other country, maybe Malaysia. So whatever happens to America and Hawaii, I still have my data center working in India. So my job will not stop. My work will not stop. And I will not miss out in anything. All the data is preserved and can be used. Every company has some recovery site. So that's the reason nowadays all the companies are mostly worldwide because of replication. And because they are doing the replications, they are also putting up the data centers. And because they are putting up the data centers, they are also starting up their work there. What is the main difference between quick migration and live migration? Quick migration can be done in a clustered environment. Live migration is free of clustered environment. It can be done between any network. Only thing is you need an internet connection. How storage migration works? It's the same way as the virtual machine is moved. The storage can also be moved. Using storage migration, you can move virtual hard disk and data files that the virtual machine is using to a different physical storage while the virtual machine is running. You can perform storage migration by using the move wizard in Hyper-V Manager or by using move VM storage commandlet in Windows PowerShell. Windows Server 2012 introduced the
storage migration feature which you use to move virtual machine data files without downtime. For example, you can use storage migration when you need to upgrade physical storage or when you need to move virtual machine storage from locally attached disk to SMB 3.0 share or SAM. You can also use storage migration to move various virtual machine items such as virtual hard disk configuration, checkpoints, smart paging to different locations while the virtual machine is running. Storage migration is performed in the following steps. Before migration starts, all virtual machines read-write operations are performed at the source virtual hard disk. When the storage migration starts, virtual hard disk content is copied over the network to destination, while all the reads and writes operations are still performed on the source virtual hard disk. After the initial copy is completed, write operations for the virtual hard disk are mirrored to both the source and destination virtual hard disk. After the source destination and destination virtual hard disks are synchronized, the virtual machine switch over and starts using the destination virtual hard disk. The source virtual hard disk is deleted. So these are the steps how the storage migration is done. Moving a virtual machine. So let's see the steps here.
I have key questions, sir. Can I ask?
Sure, go ahead.
Just the physical, the cluster failover. I just a little bit confused. Is it like for clusters, a group of servers we said, right? So how many clusters do one company have?
Unlimited. Unlimited. I mean, you can have
Well,
unlimited clusters. Each cluster can have 64 servers max.
well, like is it like the case where we taking like virtualization to decrease deploy physical server? Isn't it the case?
I am sorry, can you repeat that again?
Yeah, I think the key is like we taking this virtualization class to, company using the virtualization to decrease physical deploy server, isn't it the
Yes,
case?
yes, yes. So when we are working, so if you remember on my server, I have only one server and we have created about 10 to 15 virtual machines on my server. So that virtual machine, that means I have 15 servers. That's how it resembles.
Okay.
15 people can do 15 applications. Individual applications can get worked over. Right now you have one laptop and only you
Okay.
can work on it. But if it's a virtualization, if at that point there are 15 people they who can use your own laptop. The other thing is using this physical servers. They have big RAM and CPU. So when even your laptop has a good RAM and CPU. So if you go and see what is getting used, you will be amazed to see actually your laptop is also not getting used. See, you have paid 700, $800 and you bought a laptop. Now see what is getting used. 12% utilization. Not even 50% of RAM is getting used. I have 8 GB of RAM. Not even 50%. What about this RAM? This much of RAM is getting wasted. So I actually didn't need it this much of RAM. So if you have a, a VM installed or a Hyper-V installed, you can install many virtual machines on it, and three people, four people simultaneously can use it. And at that point, the CPU, memory, everything will be hiked up. Suppose you are doing a calculation, I am doing some painting on it, someone is reading a notes on it. So the CPU will get more used, the RAM will get more used. So it's justifiable that the money what we spend on this laptop, we are using it.
Yeah, thank
Right?
you, sir. It's clear now.
Just give me a minute. I'm trying to open the. Yes. So I have already installed Move 1 and Move 2. So let's do the demonstration steps. It says on London host 1, use Hyper-V Manager to confirm that London Move 1 is running and is configured with the locally stored VHD. So let's go ahead and check it out. So this is the server. Let me delete this. Okay. Uh, Selling. Let's select this. So in the virtual address, I have move 1 and move 2. Because the VHD is dynamically expanding and it's small, notice that the move complete use the move wizard. Okay. So let's use the move wizard. Move. Next, move the virtual machine, move virtual machine storage. So when we click on move, we got two options. Move the virtual machine. So if we are doing it, move the virtual machine and optionally its storage to another computer running Hyper-V. So if I have another Hyper-V, I can move it from this Hyper-V to next Hyper-V. Move the virtual machine storage. So this will move the storage from one location to another. Now it says move all the virtual machine data to a single location. Move the virtual machine data to different locations. Move the virtual machine virtual hard disk. You only want to move virtual hard disk. Next. So this is the name of the hard disk. Next. Where do you want to move it? So if you see this, here are my hard disk. Do you see London host 1 here? Move 1, you don't have it. So let's move it to this centralized location. Okay. Let's move it to here. Select folder. Next. Finish. Performing the move. The move is going on. If you see, moving is going on, but still I can use this virtual machine. Now the movement is going on. I am creating a folder. This is created while the GM is moving. This is created moving. Let me create notepad. Right. So I have created two files while the virtual machine is moving. It's 20% done. So when it's done completely, we will look at it. Okay. So what is the third step? Use Hyper-V Manager to confirm that is now stored on a network share. Notice that a VHD has moved while the virtual machine was running. So use the Hyper-V Manager to confirm whether it is running and configure with the locally storage VHD. And it's asking for me to move it to different locations to move to. So let's go ahead, work on move to, move. Next, move virtual machine storage. Next, move all the virtual machine data to a move virtual machine data to a different location. Next, I want to move all this. Next, so now it's asking virtual machine, virtual hard disk. Specify the location for the virtual machine, virtual hard disk. So for virtual hard disk, we are using Z share. This is the location. Next, specify the location for virtual machine current configuration files. Configuration files, we are putting it on X. Select folder. Next, checkpoint. We are again putting the checkpoints also on X. Next, smart page file, we are putting it on X. Next, finish. Now this is while this is also getting moved. This will take some time. And as soon as this is done, I will show you that these have been moved. This will take some time to move. Okay. Live migration of non-clustered virtual machines. Right now, that was the thing we just saw. It was a live migration of non-clustered virtual machines. They were not clustered. And live migration is you have an option of live migration.
I think we have done that live migration, the video which you sent to us.
Yes. So if it's live migration of non-clustered virtual machine, it's same. Only thing is you right click it and you migrate it to a different Hyper-V host. So with Windows Server 2008 R2, you can perform live migration only when the virtual machine is running on a failover cluster node and if its data is stored on a shared storage. But with 2012, but the failover cluster is no longer a requirement. Also, you can use Windows Server 2012 to perform live migration in two other ways without failover cluster. When virtual machine storage is on SMB 3.0 share, when virtual machine storage is local and on Hyper-V host, this is sometimes referred to as shared nothing live migration. Moving a running virtual machine. Again, this is the same example we did right now. Still going on. prod one is running, is configured with locally storage VHDs. It's the same thing. So I'm not going to do it again because it's moving the same virtual hard disk again. Move virtual machine and configure constraint delegation. So again, this is also going to be the same thing. Moving Hyper-V storage and virtual machine. We cannot move the virtual. We can move the virtual machine storage. We cannot move the virtual machine or do live migration because we don't have one more server to show you. Implementing and managing Hyper-V replica. To work with replica, the first thing you need to do is, let me take the server. Right click, go to settings, replication configuration, enable this computer as a replica server. You have to enable this. And then you have to select whether you will use Kerberos or you will use HTTPS. Mostly we use Kerberos with port 80. Allow replication from any authentication server. Click OK. Okay, the first setting is this. Enable this computer as a replication server. This you have to do it on the destination server. And here you need to enable replication. Click next. Replica server name. Here you have to put the server name. And if I put my server name, see what happens. Lion 6950 cannot replicate virtual machine to the same server. Enter another replica server name and try again. I don't have that option, so I cannot do it. Okay. So once the replication has been enabled, you have three options. So we cannot move forward here. So that is what the replication is all about. In Windows Server 2012 introduced Hyper-V Replica, which you can use to implement an affordable business continuity and disaster recovery solution for the virtual environment, providing you have network connectivity. You are not limited to a single site, and you can use Hyper-V Replica to replicate virtual machines to a Hyper-V host in a secondary location across the wide area network WAN link. If you have a single location, you can still use Hyper-V Replica to replicate virtual machines to your partner company.
Yep, 30 seconds, 5 minutes, or 15 minutes is the replication that you can put. So suppose you have one server, very important, but now how important? See, what happens is if you enable a replication for 30 seconds, every 30 seconds, all the data that has been worked on your server, that data will be migrated to another site across the country. So what's happening? Your internet is getting used. So every 30 seconds, if your internet is getting used, now you have to understand how much bandwidth you have, and if your internet is used for this, what about the other servers that are communicating to the rest of the world? Will that affect to that computer support? You need to think that before how important the application is and how important the bandwidth is. What if you give the complete bandwidth to this server? This is not the only server a company has. The company has thousands of servers and one internet connection. So how are they going to handle it? So 5 seconds, sorry, 30 seconds, 5 minutes, or 15 minutes. So this all depends upon, suppose if your computer, your server crashed, if you have 30-second synchronization, so that means you lost 30 seconds of data. When you have 5 minutes, that means you have lost 5 minutes of data. And if you put 30 minutes, then that means 30 minutes of data is lost. So this can be a payment information, this can be anything. So this all depends upon how important it is and how important the bandwidth is. So there is a lot of discussion between a compute, a server administration infrastructure, and and the application team to understand how to, and the vendors, like how to set up this server and for how much time of replication we can afford, our company can afford. And it's very easy. There is nothing in it. I mean, I since I don't have one more server, I cannot show you. And actually, this chapter is near completed. And this chapter is here completed. So we have completed module 5 now. So as I said, right click before you uh, configure a replication, you have to enable the replication. Enable the computer as a replication server. If I enable this, I should get a VM from someone else. Then this server can be used. And then enable replication. Put the server name, click next, next, next. It will show you. It will ask you like for how much, 30 seconds, 5 minutes, or 15 minutes. Put the data, whatever that is needed, and click on finish. Your replication is done. Initially, because it is going to copy over. So there is one more option. See, when we start replication for the first time, the server is of 100 GB. So if this 100 GB is going to transfer, it will take at least 2 days to get migrated to India, or 5 days to get migrated to India. So usually what people do is they copy it over on a pen drive, send the pen drive to the replication center, ask them to download it. So they download it. So what we are saving the bandwidth here. So
So they just download the data and then they start the synchronization. So what happens? This server is running here. They have this server complete data there, and now the synchronization starts. So either you can send it through internet, let it take how much time it has to, or you can send them a pen drive with the data to start with. And once this data is copied over, now it takes 30 minutes, 5 minutes or 15 minutes depending upon your settings, and asynchronously it will uh, synchronize the data. And if anything happens to our server A, the server B can take it over. Only five, only 30 seconds, 5 minutes or 15 minutes data will be lost. Guys, let me know if you have any questions. I'm going to stop the class now. I thought of taking one more module today, but I'm not feeling well. Let me stop.